All right, so quiz number 8 review. We're going to have 7 questions, like I said. First two are finding domain and range. Remember, domain is the x values, right? How far to the left, how far to the right. Your range is how low did it go, how high did it go, okay? So let me put that right here. So for number 1, domain and range. Remember, we use parentheses when the numbers are not included. We use brackets when the numbers are included. Okay, so the domain. How far left does number 1 go? To what was it? -3. Okay, -3. Does it include -3? Is there a nice dark circle or a? Yeah. All right. So this is going to be a bracket. And how far right does it go? +3. Does it include the +3?
No.
For the x, this is the +3 that we're talking about, okay? Right there, this x value. So yeah, it does not include it. There's an empty circle, so you're going to put a parenthesis, okay? So that's your domain for that. Range, how low did it go? +1, does it include it? No. To how high? +3, okay? So it's basically from here to here, right? From 1 to 3, you just had to tell me, was it including the 1, was it including the 3, right? So there you go. There's your domain and range, okay? There will be a question that looks very similar to this on your quiz, as well as number 2, just that the one on your quiz in number 2 is a circle. I just decided to do an ellipse, okay? So, but same idea. So domain and range. All right, so again, your domain, remember, I'm just going to draw some arrows. This is how wide it is, right? That's how wide it is. So from where to where does it go? All right, -4 to -2. There's no gaps. There's no like little circles like right here. Nothing like that, right? So it's nice and solid, which means you get to include it. Okay, range. Remember, range is basically your vertical distance, right? From where to where. So how low did it go? And how high? All right, -4 to +2. And I am going to include those because, again, there are no like little holes right there. If there was a hole on the top, I would say -4 with the bracket to +2 with the parenthesis. Okay? But there is no hole there, so no need to do that. All right? So you guys will have like a line. I think you're gonna have like one that looks like a line, one that looks like an absolute value, one that looks like a circle, and one that looks like a parabola. I think those are the 4 that you're gonna see. Are we okay with this? All right. By the way, on the homework assignment, I know some people are still working on it and trying to turn it in. I had 2 students mention to me that they keep doing it, but it keeps marking them wrong. So I'm like, okay, I'll look. I looked at their work. Here's what they were doing. They were doing domain and range for every question. But remember, some questions say just do the domain. Some say just do the range. They were doing both, so they were putting in way too much information. So I was marking them wrong. They're like, we know we're right. And I'm looking, I'm like, you are right, but you gave me both, which are both correct, but that's not what they're looking for. They just want domain or the range. And then in some situations, they were forgetting to put the parentheses or the brackets. So that's why they were being marked wrong. Okay? So if you're having issues with that, double check to make sure that you're doing that. If not, let me know soon because it's due tomorrow. So, all right. Question number 3. For some reason, this one confuses some people. I can understand because there's a lot of little steps you got to take, right? So I think there was 3 or 4 steps to this. I can't recall, but the very first step is to change your function notation to a y. So f of x is going to become a y. So y is 3x minus 3 over 2. Your next step is you're going to change your x to a y and your y to an x. Not by moving it around, just magically switch it. Okay, so x equals 3y minus 3 over 2. Okay, now you got to start solving for y, but since we have a division by 2. We want to get rid of it by multiplying it over. Okay, we're going to multiply that over to the other side. Because it is dividing, you always want to do the opposite. So it's multiplication. That's 2x equals to 3y minus 3. I'm just curious. All right. So what do I do next to get y by itself?
Add 3.
I want to add 3, right? Add 3, because that minus 3 right there is messing everything up. I'm going to go over here to this side. I get 2x plus 3 equal to 3y. One more step. All right, what do I do to get y by itself? Divide by 3, right? So yeah, divide. So here we go. I get 2/3 x plus 1 equals y. Okay? So that was step 3. So step 1, rewrite your function notation into y. So we did. Step 2, switch x with y, y with x. So we did that. Step 3, solve for y. And the last step, 4th step, rewrite your y as a function inverse notation. So this is 2/3 x plus 1 equals f inverse of x. Remember, the letter that I use depends on what they gave me. If it was g of x, I would have wrote g inverse of x. If it was h of x, I would have wrote h inverse of x. Okay? So there's my answer for that. You guys have 2 problems like that on your quiz. The front page of your quiz is 4 domain and range problems, 2 inverse problems, and then you turn it over. Okay? So the front of your quiz is relatively, it looks short. It has 6 questions. Okay? But it's because there's 4 graphing ones that it takes a lot of space. Any questions on this one? Again, I'm not saying memorize the steps, but get used to the steps. That way you know, like, okay, change it to y, flip x and y's, and then solve for y, and then rewrite it. Okay, rewrite it with the numbers. Just remember that. All right. You're going to have, I think, I almost want to say you have 4 of these. Okay? And the nice thing is, if I'm correct, they're all already solved for y. So maybe it's 2, maybe it's 4, I'm not sure. But they're already solved for y for you. So you don't have to do anything to solve it. It's going to be ready, if I'm correct. Okay, I'll double check. But this basically is a callback to when I gave you the 3 situations, right? And just to, if you guys don't mind, let me revisit this really quick, and then I think it was in section 3.1. Let me check. Yeah. In section 3.1, we did this part. Remember, I said, how many solutions can you have without even graphing it? You can tell based on the equations. You can tell it has 1 solution if the lines are not parallel. You can tell it has no solutions if the lines are parallel but the y-intercepts are different. And you can tell it has infinitely many solutions if the lines and if the lines are parallel and the y-intercepts are the same. Okay, that's all you have to remember. So if the slopes are different, 1 solution. If the slopes are the same, well, now you either have none or infinitely. So now it depends on your y-intercept. If your y-intercepts are different, there's no solution. If your y-intercepts are the same, infinitely many. Okay, so that is something I would recommend you memorize because it's going to help you do the work faster. Okay, so number 4, how many? How many solutions for number 4? My slope is negative 2/3 and 4. My slopes are different. Is that 1, none, or infinitely many? That's 1, right? If the slopes are different, it's 1 solution, okay? So it's different slopes. So I'll write it down right here. Just as a clue for you guys. Okay? These are supposed to be really easy problems. It's just you got to remember, right? Well, look at the next problem. 1/4, 1/4. Slopes are the same. So that means it's either no solution or infinitely many. It's infinitely many if the y-intercepts are the same. So which one is this?
No.
This is a no solution. Okay? So slopes are equal, y-intercepts different. So no solution. All right? So there you go. The slopes are equal, but the y-intercepts are different. If they were the same, you write IMS. I said that's the hardest part, guys. Like I can understand. I mean, I still have. Well, my senior daughter is no longer taking math this year. She decided not to, but she did it all the other 3 years and everything. And I can understand frustrations with. She would always tell me, "There's so much to memorize. There's so much to learn." And I said, "I know because math is based on definition. Like it really is. It's based on theory. It's based on theorems, postulates, conjugates, all this stuff. You have to understand all of these little things to do the work. So I know it can be frustrating that you have to memorize these things, but trust me, there's going to be times in your life you're just going to have to remember stuff, right? And once you're done with this class, if you forget it, that's fine. Hopefully you don't, right? Because right now my AP kids are struggling. What were we doing last time? Oh, we were doing a problem on related rates. I'll show it to you guys just to let you see what we're doing. So we were doing that, okay? So we were talking about how fast a camera has to change angles as a rocket gets launched into space. So you guys ever wonder, like, when are we ever going to use math? Take calculus. You'll see how we use it in real life. And they couldn't remember the trig right there. You see, I don't know if you can see next to the rocket ship on the left side, tangent theta equals s over 2,000. That's a basic trigonometric thing. They couldn't remember it from the year before. And not only that, they couldn't remember their Pythagorean theorem. You see it right here? It's just, you guys call it a squared plus b squared equals c squared, right? Same formula. They couldn't remember it. They also couldn't remember, where is it at? The volume of a cone. That's geometry, right? So they're struggling because they don't know the volume formula, right? And you might say, well, I don't remember it either. Okay, that's fine. But what I'm saying is you have to remember stuff, right? You can't, or else the math just gets tougher. So, of course, I remind them about it. It's not like, oh, well, too bad, sucks for you. But it's one of those things where it kind of reminds them that you don't just learn it and like forget it, right? You have to try to learn it and remember it. I'll write down what I tell my AB students or my AP kids. This is what I always tell them. This is what I tell them. I said, you got to learn forever. Like, you got to learn it, not just cram it, right? You want to learn it so that you can remember it forever, not just for right now. Because if you learn for now, then later on you don't remember it, right? So I always tell them, learn forever, not for now. Well, that is the life of a high school student, though. I mean, I used to do it too. I used to cram last minute, like, we have a quiz, quick study. And then after the quiz was done, it's like, oh, good, I don't have to remember that anymore, right? So I know it happens. I'm not saying that it doesn't. I used to do it. But now that I'm older, much, much older, it makes more sense. All right, so solve the systems of equations. If I'm correct, I think both of them are already solved for y for u as well, which I think I'm right on that. That's the reason why I set it up like this, because if it wasn't, I would have given you one where you had to solve for y, but I didn't, which means most likely they're already solved for you, okay? So, all we have to do is graph these, okay? All we have to do is graph them, and after we graph them, we got to check to see where they cross each other, and we're good, okay? So, let's graph the top one. I'm going to put a little red dot on it right here so you guys know that the red dot is going to be the top equation. The green dot will be the bottom equation. Okay? So, red dot. I'm supposed to start at positive 3, right? Positive 3 on the y-axis. I'm going to put a red dot right here. Okay? And then what am I supposed to do from that red dot, that 3?
Go up 5.
Go up 5 and 1's over, right? 5 over 1. But what's the problem?
There's not enough space.
All right, so I'm supposed to do the
Opposite.
opposite, right? So instead of up 5, 1 to the right, I'm going to go down 5, 1 to the left, okay? So 1, 2, 3, 4, 5, 1 to the left, so it's right here. You can always double check if you did it right by counting from the left to the right, the dots. So if I were to count from the left dot up 5, 1 over, I'd be exactly where I need to be, so that's perfect. Let me draw my line. I'll do my best. But as you guys can see, the line is not perfectly straight, which is one of the downfalls of graphing, right? If your lines aren't perfectly straight, then you're not going to get nice pictures. All right, the green one now. I'm going to start at negative 3. My slope is negative 1 over 1. So down 1 over 1. So that's going to be right here. So when I draw my line, it crosses at a point. What point is that? Negative 1, negative 2. Cool. So there we go. So this answer right there is negative 1, negative 2. And you'll have 2 problems like this in your quiz. Okay? And like I said, they're both going to be solved for y, so you don't have to worry about doing it. You just got to remember, okay, start with my b value, my intercept, and then follow my slope. If I run out of room, do the opposite, right? So instead of up, go down. Instead of right, go left. Yes, you could do substitution, which is my last example. Yeah. So she just said like we could do this also just by solving the equations like what we did in 3.2, and yeah, you guys have 2 questions like this. By the way, just so you know, on the graphing ones that we just did, you could still, when you graph them, they could be parallel, and you're going to have to say no solution. They could be the same equation. You're going to have to write infinitely many solutions. Okay? They don't all have to necessarily have a place where they cross. Okay? Graph them and then make a decision based on the picture. Okay? So the 3 solutions always count. It can either be 1 solution, no solution, or infinitely many. Okay? So that's always the case. You can always have that, even with this. So let's see, solve the system of equations. So I decided to do one that was not solved for y for anything. There is one problem there. Remember I told you you're going to have 2 of them. One of them is going to have one of the equations already solved for you. So that's the easier one. So I decided let's go with a harder one that looks something similar to this. So you get to pick an equation, either left or right side, that looks easy for you. Which one do you guys want?
Left.
Left side, I'd pick that one too. And then you're going to either pick x or y to solve for. It doesn't matter. Which one do you want to do? I mean, they're both easy, right? One is 1x, the other one's 1y. There's no number in front, so just pick one. Y, all right. So let's solve for y then. Okay, if you wanted to solve for x, you can solve for x. It doesn't matter. So I'm moving the x over. I get y equal to negative x plus 1. All right? If you would have solved for x, you would have gotten negative y plus 1. I mean, no big difference. You'd just be subbing it into a different letter, that's all. But here's my y value. Remember, if you're going by the steps, step number 1 was to separate your equation. Step number 2, choose an equation and pick a variable to solve for. Step number 3, which we're going on right now, once we solve for that variable, you're going to plug it in wherever the other the y is or the x is on the other equation. Okay? So we're in the middle of doing step 3. So this is 3x plus 3 times negative x plus 1 is equal to 4. Remember, I'm using the green just to kind of know where I plug stuff in, so you know like where this went, right? So this is 3x minus 3x plus 3 equals to 4. Okay, what happens to my 3x and 3x? They cancel out, so this is basically 3 equals 4. True or false? This is false, so what do I say? No solution, okay? So there we go. This is what you guys are going to be looking at for tomorrow.